Today is our last episode where we polish our typing trainer tool. Last time we added Markov chain text generation, which made our typing text a bit more human-y, right? So it kind of feels that some sentences were written by human, although in the end it's still quite nonsense. But if we jump into our config module, we can see that we pretty much supply things to config ourselves. And if we want to change TextSource or the ANSI colors, we need to change the code, recompile, and run the program, which really isn't the way to go. What we want to introduce in this episode are command-line arguments, and we introduce clap library to parse those arguments. I think it was episode 1 when we added this to-do in our main, where we said that, hey, let's parse this config using clap. And clap, I think, is one of the most popular command line argument parsing libraries out there in the Rust ecosystem. It's been there for a very long time. It has absolutely amazing tutorials, which you can skim through. We won't be stopping too much on clap related things, so I expect you to either know it or be able to quickly glance at those tutorials and understand what it does. But really, the things we're going to use, they're going to be quite simple, not much magic out there. So let's start with first of all adding the dependency for clap. So version 4 and features, we need the derive feature so that clap can generate code for us, the parsing part. So if we jump to our config struct, right now we have this manual config new, which we can drop. We will use clap's parser trait and ask to derive it. Now, a clap can parse many common types on its own. Unfortunately, for TextSource, first of all, it tells us that, hey, it has to be clone. And second of all, it doesn't know how to parse it using its built-in parsers, because our enum isn't simple enough. If it had only these static values, then it would be able to. But we attach data to our enum values in case we want to use file or marker chain as our text source. So what we need to do is we need to write our custom parser. So given a string that comes from command line, we would like to parse it and produce text source if possible. So that's why there's this huge error which says, hey, I need some method of getting text source from string. Before we jump into it, let's first use some claps magic to maybe let's start with text source first, just to show how things changed after we start adding clap related things. So first of all, we want to add a trait implementation for text source, which is going to be FromStr, right? So parse a value from string. It needs some missing members, type for an error, which is going to be string, and we need to implement this method from string. So given some source string which came from this command line, we need to return result, whether we successfully parsed text source or there is some error, which in this case is going to be string. Let's try to parse the string by matching source and checking what it looks like. If it's a static string, we can say, okay, well, let's make the text source static. In case it's nonsense, we are gonna use our text source generate nonsense. In case it's let's say weighted, we can say that it's going to be generate weighted nonsense. And then we have something like file followed by path, right, to do, and then some markov followed by path. So this is like how we simplify things. We expect TextSource to provide this prefix, file, and markov followed by some path. And in any other case, there should be like some error. If we jump back to our config, we can see there are no more errors. In our main, we can now drop the new, drop this to do, and ask the config to be parsed by clap. We once again need to use the parser trait here so that it picks it up. Now everything should compile as before. And now if we run it and ask it to provide some help, you can see that this is clap generated help for our program. So right now it tells us that TypeGym must include these 4 arguments. So there are no defaults for now. Everything must be supplied by us when running TypeGym. So if I try to run it, it tells us, hey, like these required arguments are there. So let's fix that. Let's tell clap that, hey, this argument, instead of using this fg_miss, let it use like long naming based on the variable name. So right now it has switched from that huge fg_miss to --fg_miss. Same can be applied to empty and results and even TextSource. Next, we can set default value t here, which was 1. In this case, default value t was 8. In this case, default value t was also 1. If we run it with help, you can see that the help actually tells you what default values are, that we can set these things, and now only the TextSource remains as mandatory. It doesn't have any default value. Let's change that as well. I mean, we can set default value is, let's default to markov with some file path, which is data markov.txt. You can see that here we're using default value t, which expects already parsed value, which should be of the same type as this variable. But in this case, we are working with default value without this _t, meaning that it expects a string like it came from command line itself, and then this whole FromStr kicks in and tries to parse it. Let's see if we run everything. It says that, hey, it's not implemented, so it tries to parse this default value of markov and doesn't know how to, because right now when we jump into this match, we end up probably here, not even here, but here, because, well, it doesn't match this one. But if we, for example, say that TextSource should be static, which we have already covered, then suddenly it works just nicely. If we say TextSource is nonsense, here is the list of our nonsense words. So the clap thingy works nicely for those things that we easily supported, but now we need to handle the file and markov cases, which we can do probably like this. So if it's not the 3 things above, we can handle it differently. So what we want to check first is the prefix. Luckily for us, we can do it this way. We can ask source to strip the prefix file, right? And strip prefix tells you that it will return the remaining part of the string when it strips the prefix, if it's actually there, right? So that's why it's an option. And in our case, if we match it on sum, it means that it actually successfully matched the file prefix. then we can do something with it. Same thing should be applied to markov chain. So with strip prefix markov, oops, I jumped correctly here, and else there is no other case, meaning that user has supplied something that we don't know how to parse. We can throw some error here, saying expected static nonsense weighted file path or markov path. Some error, else if let, right? Okay, so let's try to run it with nonsense2. And it can tell you that, hey, this nonsense2 is actually invalid value for our text source. And here is our error message. Expected static blah 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 blah. So it works really nicely. And now we can see how we can handle the file and markov paths. We still need to do some extra checks here, or extra check for the remainder of this path that was supplied with the source. So the prefix is there, but what it can follow is empty string. So if path is empty, right, then it's an error. So file path should provide file, or like expects, yeah, well, file source expects file path. For example, file data words txt. But if it's not empty, it means that there is something following the file prefix, and we can actually tell that, all right, so the text source should be file with the remainder with the path to string. Same thing can be applied to markov chain. Instead of this to do, we can say that, hey, if path is empty, then markov source expects file path, for example, markov data markov.txt. And in case everything's fine, we can then return markov chain. So this is everything that's needed to parse the incoming text source string into the text source enum value that we are working with in our config. So if I run it right now, the default is markov chain, and it works as before. So if you remember, here is the default value. So in case the user hasn't provided anything as text source when starting our TypeGym, this is being used. The string that gets into our parser, it finds the markov prefix and uses data markov.txt as the source file for our markov chain text generation. If we look now at the help, generate by clap, we can see that TypeGym expects options which are all optional. Pretty much every single one of them has some default value, and we have this text source. We can change that. For example, value name is simply source. Let's run it again. This is how you change things here, and the way we get text for a practice session, we can also help with describing what this value actually is about. Let's first probably break it down because it's going to be too long. And help is going to be like text source. What is it, like static nonsense weighted file path or markov path. Let's see again, run it with help flag, and it gives you exactly what there should be. Text source, static nonsense weighted. All right, so if we run it with text source file data words.txt, grass cow job sign. Interesting. Why did it data words.txt? Why did it only provide 5 words to us? Right? Why is it only 5 words? Markov data markov.txt works fine. So nonsense is fine. Weighted is fine. But when I do file data words.txt, yeah, of course, I forgot that file is actually takes what was it, text, I think it was get text, or actually get text. Yeah, sorry, I even forgot like what we did with file. Yeah, we're taking like just 5 lines here, so that's what it was, 5. So that's fine. So in our case, this config is now fully configurable from the outside. We no longer need to recompile the program. Everything works from the command line. Let's do another test, and for example, instead of changing text source, let's see how we can manipulate this foreground, one of the foreground colors. So for example, this foreground empty untyped character default 8. So if we run it, fg empty 8, so it's the same grayish color, but let's say 80, and suddenly it's really bright, this cyan or whatever the name of the color is. So that's great. Everything can be set via this config. Now we could wrap up here and be done, because you know, like we covered the command line argument parsing, but really I want to introduce a couple more configuration variables here in our config struct. First of all, if we look at our text, then there is this magic constant 100, which is used in all our text generation. So we're pretty much saying that, hey, please generate me 100 words. How about we extract it into config and allow the user to change it? So let's say we introduce max words. We can say that its arg long default value is 100, and make some explanation that maximum number of words in generated paragraph. And most importantly, it's all about generated paragraphs, because if we look at static or file, we do not apply this max words setting there. All right, so again, if we run it with help, we can see that, due to previous error, mistyped it like this. We can see that the new argument is right here, max words, but it's not used yet. And we have config reference in our get text, and can pass it into the methods that actually use that hard-coded constant of 100 words. Config max words. Right, let's jump into this method first. So words use size, and instead of 100, we can use max words. Same goes for weighted nonsense. Max words, and 100 is right here. And then at the end, where we generate Markov chain, we can say max words, and it should go to generate method, max words, because we use that 100 right here, right? So max words, use size. Max words. Now, if you remember last time when we worked on Markov chain, we actually talked about this internal loop, which ends up producing a full sentence, meaning that the length of Markov chain result can be a bit higher than 100. It stops only once the chain has generated a full sentence and the word's length has exceeded like 100 at that time. In this case, I want to have a hard limit of max words. So once we enter the while loop, we are pretty sure that number of words is less than max words. So the first push is fine. But the second push already needs an extra check, or the same check as before. Oh my god. Do if words length max words, and else we can instantly break from the loop because there's nothing else for us to do here. And same thing happens here in our sentence generation, only in case new word fits this max words limit, and else we can break. Let's see. Right now it's Markov chain with default value of 100, like same as before, everything works. But let's try to run it with max words 20. Nice. Right, so now we can actually manipulate how many words we want to generate. Let's say 3, right? Yeah, set Alice hastily. Very nice. We can have different text source. Instead of Markov chain, we can use nonsense, right? Flower by chance. Lock subject what? Lie, leave, child. All right. Works nicely. So this max words is something that we hard-coded, and now the user has the ability to manipulate that value. And one last thing that I want to add is the ability for user to restructure or reflow the text. So once again, there is one and there is another constant that we use is this chunks 10, where we end up with 10 words per line, right? So selected words, chunk 10, with we use join them by space. Pretty much in our generated text we have 10 words per line. In our read from file we have whatever the lines have. In chain again, I think it was 10, right? Chunks 10. But this time we won't manipulate this chunks 10 because we want to also apply this thing to both static text and the file input. So first of all, we will introduce a flag named reflow, which is a boolean. We can say that, yeah, let's add long argument, default value t is false. So only when user actually sets this flag, we will apply this reflow. So reflow text using target width. And what's our target width? That should be another param here, width, usize. We can say that it should be, once again, long argument with default value t of, let's say, 80. And this is maximum number of characters per line in reflowed text. So once the reflow is enabled, we want to use this width and try to make lines as big as this value, but not more. They can be less, because if the word doesn't fit, we start a new line. If we run our help now, then it can tell us that, hey, there are 2 arguments with reflow. But the thing is that if we run it with width 10, it still works. But really, width should only work when reflow is on, right? Because it's only applied in reflow text. So what we can tell is that it requires our reflow, right? So it requires the reflow to be set. If we try to run it again, it will actually tell you that, hey, the following required arguments were not provided. So reflow must be set. We set reflow and it starts. It's working. Where do we apply this reflow? We apply it in our get text. So here we actually grab the text from the source, either static, we generate nonsense, weighted nonsense file, markov chain. In this case, currently we simply return it to our UI module, which then shows this text. But what we want to do is we want to capture the text first, right? We capture it and then check if config reflow, if the reflow flag is set, right? Then we do something, but otherwise we can return the text as it was. So right now, if I run it without reflow, it continues to work. The Markov chain text generation works fine. But if I apply the chain, I need to somehow restructure the text that was generated from one of these sources. And we don't even care about the source. Let's say that is going to reflow text and config width. So we're gonna restructure our text using this width, whether it was supplied by user or we use the default value of 80. Now we need this function reflow, which is going to return a new string, given that we receive text as an input with some width of use size. Right? And this is a to-do. So what should reflow do? Reflow should once again split the text into words. It should then try to go word by word and try to add it to current line until it hits the limit of this supplied width. When the limit is hit, we start a new line. That's pretty much how we end up with like reflowed restructured text given this width limit. So let's quickly implement that. First of all, we need our lines, which is a vector. Then we need our current line, which is a string. And we need to keep track of what our current line width is. Initially, of course, it's 0. Then we need to iterate over all our words in text. We split by white space. We do some magic here. Yeah, let's instantly go here. So first of all, we need to check whether our current line is empty. Oops. So if it's empty, we really want to push our word into this line, disregarding what the width is. So for example, if width is 1, we still want to push the word onto the line. So our line will always have at least one word, regardless of what the width is. Because if the width is 1, we pretty much cannot add any words, and that doesn't make sense. So that's our compromise, where we add at least one word to the line. Meaning that we can say line push str word, and line width is our word width. And what's the word width? It's actually word due to UTF-8. We need to grab its chars and count it. Let's add to do here so that it doesn't complain. Next, we process the word and the line is not empty. So what we want to do is we want to try to add current word to current line. Meaning we need to check whether current line width plus 1, which is for our space, because we grab lines content, add space, and add a word, plus word width is less than or equal to this width limit. Else if. And if we enter this else statement branch, it means that the word can fit. So we can actually push the space, then push the word, and say that line width has increased by 1 space and the word width. And finally, if we end up in this final else statement, we know that the line is not empty, so there is some content, and the word cannot fit. We cannot put the word into this line, meaning that current line needs to go into our lines vector. It's like actually lines equals, right? Small mistake. So lines push current line. Our line becomes what? It becomes our word to string, and line width becomes words width. So once we have processed every single word, we now have vector of lines, and we can end up in a situation where the last line has a few words in it. It hasn't hit the width limit. So we must check if line is not empty, then we need to push it into our lines. So this is like the last line which can contain last few words, which is less than width limit. And finally, we can return all lines joined by new line. And this should be it as to how to reflow our text. Let's try to build it. Build is clean. If we run it without any arguments, we should end up in our Markov chain generated text, and we can see that there are 10 words per line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's try asking it to do the reflow with width instead of 80, let's say 30. And as we generate a lot of words, let's ask for max words. It's 10. Right, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 words. 20 words. Looks good, right? Did not appear. Now, if we grab our text source, which was static, if you remember, this is our static text, which has been hard-coded. We can actually ask it to be reflowed. By default, the width is 80, and we can see that it removed those extra spaces just because we are breaking down the initial text by words again and construct new lines. Again, we can say that width is, let's see, like 40, okay? And it works nicely. So this reflow, quite an easy logic, and produces a very nice result. So that's pretty much about it, about command line argument parsing. We could definitely do a different way. There are many ways that you can work with clap. This one seems to be just fine. It achieves our goals, doesn't produce any complicated code, looks a bit like magic, but if you read the tutorial, you will most likely understand everything that we went through today. So I guess this concludes this series where we built a typing trainer. Hope you liked it, and I'll see you again when we start something new. Bye.